So we are going over complex fractions. And a complex fraction is like a fraction that has fractions inside of it.
Oh my God.
Fractions made up of other fractions.
Alright, this is fraction.
Alright, so for the first example, we're going to do 11 over x plus 3 over 2 divided by 5 over 2. 11 over x plus 3 over 2 divided by 5 over 2.
Wow. We don't get paid enough for this.
You don't get paid at all.
Exactly.
Alright, so on the top, I can see that two fractions are being added together, and anytime we add or subtract fractions, what do we need?
Common denominator.
Common denominator. Okay, so what would the common denominator be, not just for these two fractions, but for the whole thing?
2x.
2x. We need a 2, we need an x. So what does the first fraction need?
2.
2. What does the second fraction need? What does the third fraction need?
Yes.
Alright. So that gives us 22 over 2x plus, what's my next one?
3x on 2x.
Divided by
5x on
2 x's.
So far, not too bad, right? We've done all these things before. I'm going to go ahead and combine my top two fractions into one because I'm adding, so I can do that. So on the top, I have a denominator of 2x, and then I'm going to have 22 plus 3x, and those are not like terms, so I'm just going to write it like that. So now I have one fraction divided by another fraction. Go ahead and divide up my steps here. I don't know if that helps or not. Okay. So we got one fraction divided by another fraction. What do we do anytime we have one fraction divided by another fraction? Keep, change, flip. So keep the top. 22 plus 3x over 2x. Change it to a multiplication problem.
2x over 5.
And then flip the other one, 2x over 5x. And at this point, what do you guys see? Yeah, you can cancel the 2x's. What were the 2x's in the problem? They were the common denominator. I want you to keep that in your head. We just canceled out the common denominator. Okay? Right? That's the only thing that canceled, right? All right, what do we have left over? And what are the two words we always finish these problems on? Factor cancel. That's what we finish on. So a complex fraction is taking everything that we've learned. Like on the warm-up, we had 1 through 4 was just keep, change, flip, factor cancel. 5 through 8 on the warm-up was get a common denominator, factor cancel. Complex fractions are saying do all of it in one problem. That make sense? Okay. Now there's a fun trick to complex fractions that makes them way easier. We can go back to the beginning, back right up here. So our first step was to figure out what the common denominator was, right? 2x. Second step was to fix it so all the fractions had that common denominator, right? Multiplied by 2, multiplied by x, multiplied by x. And then we know that all the way down here, we're going to get rid of that common denominator, right? So what I propose is we don't do any of this work. Let's not do any of this. Let's just say, all right, I have a common denominator, now I'm going to get rid of it. So get rid of your common denominators. What do you see is left over?
The answer.
And what do you notice? That was the answer.
Is that always a rule of thumb?
Yep.
Every time?
Every time.
I understand.
Yep. So as long as you get a common denominator for every single fraction, this trick works.
Why didn't you tell us that before we did all the work?
Because I wanted you to know where it came from.
No, bro.
Okay, at least I only made you do it once and didn't make you do it until you figured it out for yourself.
I'm done.
Alright? So, now here's what I will say. I have had, are you listening?
Yeah.
I have had students who have forgotten the trick on their test, but because they understood how fractions worked well enough, they were still able to go through the process. They were able to say, oh, I see an addition problem, so I need a common denominator. And then they were able to do the keep, change, flip, and they were able to actually get the problem right even though they forgot the trick. So it is beneficial to actually understand where the trick comes from. However, this little trick does work every time as long as you find a common denominator that works for your entire fraction. So every single fraction within your complex fraction has to have the same common denominator because we need this step to have happened for us to be able to cancel out the denominator in the beginning. Yes, sir?
Or would there be a situation where there would not be a common denominator for the bottom part?
Only if you did not make it happen.
Okay.
So it would be up to you. As long as you make it happen so that the common denominator is everywhere, then this trick works. But it has to be everywhere.
So can that always happen?
Mm-hmm.
Okay.
You can always make it happen. All right, example 2. So now we're going to use a little shortcut so we don't have to waste our time.
What should be harder?
Second example is x over 2 minus 2 over x divided by 1 over 3.
Yes, it is 6 there.
Yeah, so our common denominator needs a 2, needs a 3, needs an x, and that gives us 6x for our common denominator. Okay. So this one has 2. What does it need?
3x.
This one has an x. What does it need? This one has a 3. What does it need?
2x.
And then, what do we do now? Yeah, get rid of all your denominators. So we're getting rid of the denominators because we know if we simplify this all out by hand, the denominators would eventually cancel out. So we're just... Just 12 over 2x. Mm-hmm.
Take the common denominator.
And then our last 2 words we always do. Factor cancel. Can we factor this problem? Yes. GCF of 3.
That's what I'm about to say.
Weird. Oh yeah.
Can we factor some more?
No. Wait.
Yeah, difference of squares. Do you guys see that? X squared minus 4. Difference of
Wait, we
squares.
take the 2x out though. Oh, never mind.
So difference of squares means we have 2 sets of parentheses, one with the plus, one with the minus. So what are our parentheses?
2.
Yeah, x plus 2 and x minus 2. Now that we've got it completely factored, is anything canceling? No. So that means that we could have left it here, since nothing ended up canceling. This is a good answer. If you couldn't see that nothing was going to cancel and you needed to factor it this way before you could see nothing was going to cancel, then this answer is fine as well. Or this answer at the end. All 3 of these answers are equally correct. All of them get full credit.
So if I left it all the way down at the bottom,
Yep, this one is good. Full credit. Full
but
credit.
the next
Full
one's
credit.
Okay.
All of them are full credit because they're all the same.
Nice.
All right, example 3. (16 over 5 over x minus 16 over 5. This one is a little weird. Does anyone notice what's weird? Take Say it again?
16.
Yeah, the 16 is not a fraction. And remember, we said that this would work as long as all of our denominators in the problem are the same thing. So that means we can't leave this as a whole number 16. We got to write it as a fraction. Got to put it over 1.
Oh my tornadoes.
So our common denominator needs... Yep, needs a 5, needs an x. So this one needs a 5x. What does this one need? Needs a 5. The bottom only has an x, so it needs a 5. This one's got a 5. It needs an x. All right, and then what do we do? Yeah, get rid of all those denominators. So 16 times 5x, 80x. And this is
25.
and the two words we always finish with, factor cancel. Can we factor?
Yes. No. Yes.
You cannot probably.
No.
Sure.
Cannot. Cannot. We agree you can't.
You cannot.
Yeah, you can't factor it. So we are done. So one of the things to notice is if you can't factor it, it can't be simplified. It's done. All right. To be able to simplify it, you have to factor it first. That's the mistake that we keep making is we're simplifying stuff when it's not factorable. Okay. So you have to factor so that you can simplify something. All right. Did you still have a question? Yeah. All right. Example 4. Now that we've got the idea down, we're going to do some that have more difficult denominators. So we're going to do 5x over 3 plus x over x plus 1 divided by 2.
Sorry.
We need a 3, we need an x plus 1. We do not need a 2. Why don't we need a 2 in our common denominator?
Whole number.
It's a whole number, yeah. So since that 2 is a whole number, what should I do? Put it over a 1. Yeah, so I need a 3 and I need an x plus 1.
That mess up a lot of people on the system.
It sure does. All right, so the first one has a 3. What does it need?
X plus 1.
X plus 1.
I have a question.
X
Do you
plus
always
1.
have to turn the bottom? The whole number into a fraction?
Mm-hmm. And that's because we got to have that common denominator to all cancel out.
Yeah.
They got to all be the same, or else our trick doesn't work.
But I mean, like, if you were doing it without the trick.
If you were doing it without the trick, you would not need that to be a fraction. If you were doing it without the trick and you were completely doing it by hand, you could leave it as 2 over 1.
It is like easier now.
But if you're doing the trick, they all got to be the same. All right, this has an x plus 1, so what does it need? 3.
3.
This one's just a 1.
So it is a 3.
It needs a 3, and it needs an x plus 1. All right, and then what do we do? So all the denominators go away. Five x squared plus
3.
wait 5x squared plus 5x plus 3x divided by. So we did 2 times 3 is 6. And then we took that 6 and we distributed it. 6x plus 6. Okay. You can GCF the top, but we want to combine like terms first. So what do we have on the top?
5 squared plus 8x.
Oh,
Okay, and our last 2 words are factor cancel. So what type of factoring can you see? GCF of x. What's left over?
5x plus 8
GCF of 6. And the leftovers are. Did you guys notice that it was in factored form right here?
Yeah.
And we multiplied it out? Then we had to factor it again.
For what?
When you get, you don't have to do that. When you get better at these problems, you'll be able to recognize like, oh, I shouldn't multiply that out because it's in factored form. I want it to be factored. But if you think about like this one, if we had left this one in factored form, we would have got our answer wrong. You had to multiply this one out so you could combine and take terms. So you just got to be careful. Does anything cancel once we have factored it?
no.
So that means that this is a good final answer. It also means that this was an okay final answer. These answers are both worth full credit. They are equally accurate.
I'm accurate.
Only pronounced correctly. All right, last example. One last one.
Examples.
5 examples. Oh my god. All right, A over 5 over A plus 25 over A minus 3. Last one. We need an A
Hey man, what you doing?
and an A minus 3. I'm real close to just moving all these down.
Are you gonna put it over 1?
Put what over 1?
The A at the top.
The A at the top, we put over 1. Okay. Then what do we do?
See what other denominator needs.
Yeah. So what does this one need?
That needs the whole thing.
The whole thing. So it needs an A and an A minus 3. It needs an A and an A minus 3. What does this one need?
A minus 3.
A minus 3. That needs an A. And then what do we do? Get rid of the denominators, ditch them. Okay, so this is, we got an A and an A here. What's that?
A squared.
A squared. So I've got an A squared times A minus 3.
It's A cubed minus 3A.
Okay, so A cubed minus 3A. Alright, what do we have here?
Plus
Let's shoot.
5. That's 5A. And plus 52. That's minus 2.
And then what do we have over here?
25. Plus 25.
Plus 25A.
25.
Okay? So now what can we do?
5A minus it's 15. Factor.
Oh, they all. What'd you do?
Oh, it's 15. It's not 15A. Sorry.
Yeah.
That's just 15. My bad.
30. So
We gotta combine like terms, right?
30A. That's still be minus 3. Still take a 5 out.
Yeah. But you can actually take more than a 5 out.
Oh, that is true.
Yeah. So what type of factoring do we have that we can do?
GCF.
GCF?
Take out
15. Okay, so on the bottom we're taking out 15, and what does that leave us with?
A minus 1.
Over 2.
2a minus 1. It's a to the third because it was a squared, and then you distributed
What
a
else?
squared.
Oh my.
A squared times a negative.
Oh, minus 3a squared. Thank you so much.
Oh, I did put that in.
Whew.
Wait a minute, what?
We forgot when we were distributing this a squared. We missed the a squared right here. Yeah. Sorry, guys. All right, and then what do we have on the top?
A cubed.
Can you factor that?
Yes.
It's just this, right?
Yeah.
It's what we had before we multiplied it out. Okay, a squared times a minus 3. Does anything cancel?
Nope.
Nope. So that means that this was a good final answer, but so was this. They're both good final answers.
So, is there a way of us knowing if it's a good answer before going into like doing the whole?
You can factor it in your head and just not write it down, and then think about whether or not it would cancel. But no, there's not another trick to it.
Okay.
So either one of those is good. All right, that is all.